All right, so today's notes are on sine, cosine, cosecant, and secant transformations. So sine in its reciprocal and cosine in its reciprocal. If you look at the beginning of these notes, these should look pretty familiar because we did an exploration on it. So we've actually already graphed both of these, but let's actually put these in our notes and know that we have to know what this looks like. Okay, so it says use the unit circle to sketch a graph of the function y equals sine of x. So really quickly off to the side, I'm going to draw a circle, the unit circle, okay? And if you look at the x and the y axis, you can see that you only need the quadrantals for what we've asked you for now. Okay, so this is 0 degrees and 0 radians. This is pi over 2 radians. This is pi radians, and this is 3 pi over 2 radians. This is also 2 pi radians. Now I'm going to do my ordered pairs. This is over 1 up 0. This is over 0 up 1. This is left 1 up 0. And this is over 0 down 1. Now remember, all my ordered pairs go cosine comma sine. So my sine values, or my cosine values are my x values. And then my sine values are my y values. So these are my sine values here. Okay, so I'll just use that color coding there to help me when I go to graph it. Okay, so let's go graph these. We're going to start by plugging in 0. Okay, we're going to plug in 0. So I want the sine of 0. Sine of 0 is this y value right here, which is 0. So there's my first point, 0, 0. The next one's sine of pi over 2. That's the y value right here, which is 1. The sine of pi, the y value right there, which is 0. 3 pi over 2, the y value right here, which is negative 1. And then the sine of 2 pi, which is going back to this right here, and that's 0. So this right here is, once I connect these points, is one cycle of the sine function when I connect these points right here. Okay, so if you look, this piece right here looks the top half of the unit circle. This piece right here looks like the bottom half of the unit circle, okay? Now, oopsies, I didn't want to undo that. That's okay, I can redraw it. Okay, so I only drew one cycle, but what I want you to realize is that this continues on forever and ever. So like if I asked you to plug in negative pi over 2, which this is also negative pi over 2 right here, right? That value, the sine value there is negative 1. So I do have this point right here, and then pi would be 0. So there, it does keep going on forever and ever this way, forever and ever this way. And you'll see a lot of times that there'll be arrows like that. I hate that because to me this means that it's leveling off. To me this means it going up forever. But there's no real way to show that it goes on forever and ever, okay? But it does go on forever and ever. The pattern continues in both directions. Instead of me putting this red in here, that shows that it goes on forever, what I'm going to do instead is I'm going to go like this and say pattern continues. And I'll go like this and say the pattern continues. I'll go like this and say the pattern continues. Now, you're only ever going to draw one cycle, so you're never going to have to write pattern continues, but I want you to know that it does, okay? So I'm going to leave it in because I have to answer one more question based on it, and then I'll erase it. I should have just left it the first time. I just need that part to answer the next question. So the next question says, or not, the next part says, now graph the function on your calculator. Is the function even or odd? So I need this red part to tell whether it's even or odd, because remember, to tell if it's even, it's a reflection over the y-axis. So here's my y-axis right here. And it's not a reflection over the y-axis because you'd have points here and here. And if it's odd, it has 180 degree rotational symmetry, which this does have 180 degree rotational symmetry. If you turn your iPad upside down, this would look exactly the same. So, therefore, it is odd. Okay, so I'm going to circle or highlight odd. And the reason why is because it has 180 degree rotational symmetry, or symmetry about the origin. Okay, so this sine cosine parent functions box, we're going to fill in that last because it says sine and cosine. We haven't done cosine yet. So to graph cosine, I'm going to switch back over to blue because I feel like it. And now I'm going to do the cosine values. So the cosine of 0, right, because I'm plugging in 0 here first, and then I'm going to keep going. So the cosine of 0 is this x value right here, which is 1. The cosine of pi over 2 is 0. The cosine of pi is -1. The cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. I don't know why there's an arrow pointing to that, because I might have accidentally did that. Okay. All right, so now I'm going to graph this. Remember, this is a cosine curve. So this is not V-shaped. This is like the upper right-hand side of the unit circle. This is like the upper left-hand side of the unit circle. And this is like the bottom part of the unit circle. Okay? So, once again, this pattern continues. Like if you wanted to show that, you could plug in values. But this does continue on and on. I'm going to erase those dots in just a second, but I have to answer this question here. Now graph the function in your calculator. We don't need to do that. It's right in front of our face. Is it even or odd? So this time, if you look at the y-axis right here, this is a reflection over the y-axis. So this is even. So let me erase this red stuff here because I only want you ever to graph one cycle. So this is even. So now let's go back and talk about a couple things that I've mentioned. So first off, this right here, from this point to this point, that x value, this is called one cycle. Okay. Another thing that's important is this line right here. This line that goes right through the middle of the graph, that's called the midline. Okay. Now, what I want you to notice about a sine function, the pattern, how I remember it, is that it's on the midline, above the midline, on the midline, below the midline, on the midline. So on above, on below, on. There should be 5 points that you're graphing when you graph the sine function. All right, if you look at cosine here, this right here, from this point, from this x value to this x value, this is called one cycle. Okay. If I draw in the midline, I'll do that in yellow again. So the midline goes right through the middle of it. What you should notice here is that for cosine, it's above the midline, on, below, on, above. Okay, so above, on, below, on, above. And that's how I remember it, and honestly, that's how most people end up remembering it, because we're going to draw on our midline, and then when we have to make cosine, we know we go the highest it goes on, the lowest it goes on, the highest it goes. Okay, so now let's talk about a few things here. Let's talk about the domain, the range, the period, and the amplitude. So first off, the domain. Okay, now if you just look at that blue piece, you might say 0 to 2 pi. But remember I said that the pattern continues. Okay, the pattern continues and goes on forever and ever and ever. So the domain of both of these, and I should have written it right here, but to save myself, I'm going to do copy, paste, copy, paste. There. Now I saved myself there. The pattern continues on forever and ever in both directions, so the domain is all real numbers. The range, the lowest both of these goes, so if you look here, this is the lowest it goes, this is the highest it goes. So the range on both of them is -1 to 1. If you look at cosine, it's the same thing. The period is the length of one cycle. The period is the length of one cycle. So it might be sounding right now like you're in anatomy class. Also because this kind of looks like a uterus right here. I'm not going to lie, in fallopian tubes. That's what people always tell me in class, so I'm going to get it out of the way and say it. The period is the length of one cycle. So if you look at how long this cycle is right here, it goes from 0 to 2 pi. So the length is 2 pi. If you look at sine, it goes from 0 to 2 pi. So the length is 2 pi. The amplitude is the distance from the midline to the highest point or the midline to the lowest point. So if you look right here, I want to know what distance from here to here is. The distance from there to there is 1. And if you look from here to here, it's also 1. So the amplitude of the parent function is 1. Okay. All right, so for now what we're going to do is we're going to graph cosecant and secant. I'm going to do it pretty quickly, and if you're like, wait, what does it look like? Don't worry too much because we're actually never going to ask you to graph it. This box is what we're going to ask you about. Okay, so these are the things that you're going to need to know here. So cosecant is just the reciprocal of sine. Okay, so cosecant's reciprocal of sine. So we're going to graph cosecant first right here. And we're going to graph it to the left here. So I have to switch all my x and y values, or I can flip them over the line y equals x. But I still have a point at pi over 2 pi. Or actually, no, let's instead of me just explaining it like that, I'm going to go through it really quickly. I'm going to redo the reciprocal of all my y values. So the reciprocal of 0 is undefined. So it's undefined at 0. The reciprocal of 1, because now I'm right here, is 1. So there's a point at pi over 2, 1. The reciprocal of 0, once again, because now I'm at pi, is undefined. So I have another asymptote there. The reciprocal at 3 pi over 2, which is -1 right there. The reciprocal of -1 is still -1. And then back to 2 pi, the reciprocal of 0 is 0. Sorry, the reciprocal of 0 is undefined. I don't know why I said that. Okay, so this is what it starts to look like. And if you're like, oh, that's not helpful because these, I'm going to change the color. These blue points right here are actually the only 2 points I have right now. But if you think about it right here, so this is downward facing right here, this piece that I'm going over and over again with. It's just that flipped. So it's upward facing now. And it goes on forever and ever because it's not going to meet up with the other piece. Same thing here. This is downward facing. And then that pattern continues on forever and ever and ever. Right? All right, let's do the same thing with secant. And this, once again, there's an asymptote here. And then there's a piece that's right here. And it goes on forever. Okay. All right, so let's look at secant now. So secant's reciprocal of cosine, so we can do it the same way. So I'll start at 0. The reciprocal of 1 is 1. So we have a point at 0, 1. At pi over 2, the reciprocal of 0 is undefined, so we have an asymptote there. At pi, the reciprocal of the x value, which is -1, is -1. So much easier to show you this on the board in class. The reciprocal of cosine at 3 pi over 2, the reciprocal of 0 is undefined. So there's another asymptote right there. And then the reciprocal at 2 pi for cosine, the reciprocal of 1 is 1. Okay, so now when I want to draw this, I need to do, okay, so if you think about it, it's this piece right here. It's flipped, right? So it's going to be upward. Like that. This piece right here is like an upward facing parabola. So this is going to be like a downward facing parabola. And then this piece right here, bless you, is up and to the right. This is going to be up and to the left like so. So that's what one cycle of secant looks like. Now if you look at the period of both of these, which remember is the length of one cycle, starts here, ends here. It's from 0 to 2 pi. It's 2 pi. Starts here, ends here. 0 to 2 pi. The period is 2 pi. Now it says there is blank, and I want to talk about the amplitude. So the amplitude is the distance from the midline. So if you look right here, if I draw it in the midline in yellow, and if I say how high is the highest point, it goes on forever and ever and ever. So I cannot measure that distance, therefore there is no amplitude on cosecant and secant. Amplitude. There we go. There's no amplitude on cosecant and secant. Okay, so what we're going to do next is that you're going to be given a trig function, and I'm going to ask you to find the amplitude, the period, the phase shift, and the vertical shift. Now, you need to be able to do these things in order to graph. So once you're able to do all of these things, you can graph. So let's see how we get all of these. So this right here is our basic trig function. So it says the portion of each graph on 0 to 2 pi represents one period or cycle of the function. Notice that the cosine graph is a horizontal translation of the sine graph. It's just moved to the right. Any transformation of the sine graph is called a sinusoid. So these are called sinusoidal graphs. The general form of a sinusoidal function for sine and cosine is, and then it's this, y equals a times whatever trig function is, sine or cosine, times b times the quantity of x minus c plus d. Okay? All right, and then it's b times the quantity of x minus c. It's not the trig function times b. Okay, so the variable that represents amplitude. Okay, so amplitude is a. Now, amplitude is a distance, so that's one important thing that you need to know. So it's actually the absolute value of a. So if it's -3, the amplitude's 3. It is, once again, this is the only one we're going to write down a definition of. It's the distance from the midline to the min or max. Okay, next we're going to talk about the phase shift. Okay, phase shift is just another way of saying the horizontal shift, but we call it a phase shift. So it's how far it moves left or right. If I asked you to guess which one controls how far it moves left and right, I think everyone's going to say C. And C is your phase shift. It's going to move it left and right. So now remember, if it's a negative number, if it's a minus C, so like if the minus is actually here, that's going to be right C. And if it's plus C, then that's left C. Now, please don't misinterpret what I'm saying here. It's if you physically see with your eyeballs x minus 2, that means it's right 2. If you see x plus 2, then it's left 2. So I'm just trying to help you out with what you physically see. Okay. Next, we have, let's do vertical shift next, because once again, most people can say like, oh, I bet you that's D, and it is D. I don't know why I highlighted the plus 2. Let's just do D. And that's going to move you up or down. Okay, so if it's a positive number, a positive D, you're going to move it up. And if it's a negative number, you're going to move it down. And it's the value of D, whatever that is. All right, next is the period. So we already said that a non-transformed cosine or sine graph has a period of 2 pi. But there could be a b value that changes the period. So the period is not, oops, I don't want to use red. The period is not b, okay, but it's whatever 2 pi divided by b is. So we're going to take 2 pi, which is the parent, the period of the parent, and you're going to divide it by the b value, okay? So one thing that you have to remember before you start is if you look at this equation, b is always factored out of this. The lead coefficient on x has to be 1. So if there is a value other than 1 in front of x, b has to be factored out. So remember to always start by factoring out b. So the first thing I'm going to do is I'm always going to ask you, what is b? And if your answer is something other than 1, we have to factor it out. Okay? All right, let's get started on this practice here. Find amplitude, period, phase shift, vertical shift of each function. So here's my function. The first thing I'm going to ask you is what is b? B is the coefficient in front of x, so it's 1. So since b is 1, we do not have to factor out b, so we can just answer these questions. A is the coefficient in front of your trig function, so a, your amplitude is 1. Next, let's do phase shift. We're going to do phase shift, vertical shift. We'll always do period last. All right, so my phase shift right here is pi over 2. Make sure you're using the words right or left. Since this is a minus pi over 2, this is right pi over 2. Vertical shift we'll do next. Vertical shift, this is a plus 3, so we're going to use the word up 3. Please don't just put 3. Please don't put plus 3. Please make sure you use the word up or down with vertical. And make sure you use the left or right with phase. All right, last but not least is the period. So the period you get by doing 2 pi divided by b. We already said b was 1. 2 pi divided by 1, 2 pi. All right, let's try another one. So first off, what's the b value? Once again, b is the coefficient in front of x. It's 1, so I do not have to factor it out. Here's one thing that helps people. Do you see how this has parentheses in it and this one doesn't? So we want to draw in the parentheses so that we answer these questions correctly. If there's no parentheses drawn in, that's because it's around x and it's unnecessary. Please understand that it's not around x minus 4, because if it was around x minus 4, it'd be there. It's only around x, and that's why we don't need them. So I'm going to keep them drawn around x here. All right, amplitude. Amplitude is the a value. Remember, it's the absolute value of the a value. So the amplitude is 3. Phase shift. If I look inside my parentheses right here, there's nothing being added or subtracted off of x. So there is no phase shift. So we're going to say none. Vertical shift, that's this right here, down 4. And then once again, the period is 2 pi divided by b. b was 1, so it's 2 pi. All right, next one. What's the b value? The b value is 2, so I have to factor out the 2. So I'm going to do y equals 2 cosecant of, and now I'm going to factor the 2 out. Remember, factoring it out is the same thing as dividing it out. So if I divide 2x by 2, I get x, minus, if I divide pi by 2, I get pi over 2. Remember, factoring out is the same thing as dividing out. All right, so now we're ready to answer these questions. First off, I want to know the amplitude. The most common incorrect answer is 2. Now, the reason the answer is not 2 is because this is cosecant, and cosecant has no amplitude. So there is no amplitude here, so you can put none, or you can put NA for not applicable. I usually put NA if it doesn't apply to that one. Also, I should have said, like, this is cosine, so it has amplitude. This is sine, so it has amplitude. Okay, phase shift. I can tell right here it's moved right, pi over 2. Vertical shift, this is down 1. Period, 2 pi divided by the b value, which is 2. And then I can simplify this because 2 divided by 2 is 1, so I just get pi as my period. All right, next one, what is the b value? The b value is 3, so I have to factor it out. So I'm going to factor out or divide by 3. So I have y equals 5 times the sine of, I'm going to factor out that 3. Factoring the 3 out of 3x is easy, it's x. But what about factoring the 3 out of pi over 2? Now realize when I factor out the 3, I have to divide it by 3. So I'm dividing by 3. Now, I don't like dividing by anything, a fraction by anything, so I'm going to instead multiply by the reciprocal, and you can see that you get pi over 6. So another way of doing it is saying if you're dividing by 3, I can just put it in the denominator. So this is plus pi over 6. All right. Or you can say dividing by 3 is the same thing as multiplying by a third. That's what I'll probably do for the rest of the time. I have to divide by 3. It's dividing by a fraction. I'm going to multiply by a third. Okay, amplitude. This is sine, so it does have an amplitude of 5. Phase shift. This is left, pi over 6. Vertical shift. There's nothing here, so there is no vertical shift. None, or you can put not applicable. Period. 2 pi divided by b. b is 3, so 2 pi over 3. 2 pi over 3 is not simplifiable, so that's it. All right, the rest is practice here. So I'm going to go through it because they're all a little bit different. All right, so there is a b value. What is the b value here? It's 2 pi. So I'm going to factor out a 2 pi. So I have 3 secant of 2 pi times. Now I'm going to divide out a 2 pi or factor out a 2 pi. So this will cancel that 2 pi out of there. So that's just x. Plus, and then I'm going to divide out by a 2 pi here. So if I divide it out or factor it out, I can just look at it like that. The pi's cancel. Realize there's a 1 right here, so this becomes 1/2. All right, amplitude. This is secant. Secant does not have amplitude, so not applicable. Phase shift. This is left 1/2. Vertical shift. There is no vertical shift. Period. 2 pi divided by b, which is 2 pi. 2 pi divided by 2 pi is 1. All right, next one, what's the b value here? The b value is 1/2, so I have to factor out a 1/2. So I have -4 cosine of 1/2 times the quantity of x. Now I need to factor out the 1/2. So now realize I'm dividing by a half. Okay, divide this by half, it's gone. Divide this by half, and I might be saying to myself, "Oy, divide by a half. I don't like dividing by fractions." So instead, I'm going to multiply by the reciprocal. Okay, multiplying by the reciprocal, you get 2 pi over 4. 2 goes into itself once, 2 goes into 4 twice. So this is plus pi over 2. All right, amplitude, it's cosine. So cosine does have amplitude. It's 4. Remember, the negative does not go with it because it's the absolute value. It's a distance. Phase shift, this is left, pi over 2. Vertical shift, there is none. Period, 2 pi divided by b. I'm about to divide by a fraction. We don't divide by fractions, so instead, I'm going to multiply by the reciprocal. So instead of dividing by 1/2, I'm going to multiply by 2 over 1, and I get 4 pi. Okay? All right, next one here. What's the b value? The b value is 2. So I'm going to factor out the 2, or divide by 2. So I have negative secant, factor out the 2, that's x, plus, factor out the 2, which is pi, plus 1. So that one was nice and easy. All right, amplitude, this is secant, so there is no amplitude, so this is not applicable. Phase shift, that's left, pi. Vertical shift, this is up 1. Period, 2 pi divided by b, which is 2. 2 divided by 2 is 1, so the period is pi. All right, next one, what is the b value? The b value is pi over 4, so I have to factor out a pi over 4. So I have y equals 5 times the cosecant of, I'm going to factor out a pi over 4. Remember, factoring out a pi over 4 means dividing by pi over 4. So that'll cancel. That's x minus, and then I have to do pi divided by pi over 4. I don't divide by fractions, so instead I'm going to multiply by the reciprocal. Okay? So remember, you can put this over 1. You got 4 pi over pi. The pi's cancel, so it's just 4. And then plus 9. All right, my amplitude, this is cosecant. Cosecant does not have amplitude, so this is not applicable. Phase shift, this is right 4. Vertical shift, this is up 9. Period, 2 pi divided by b. b is pi over 4. I'm about to divide by a fraction. I don't divide by fractions, so I'm going to erase it. And instead, I'm going to multiply by the reciprocal, which is 4 over pi. Okay, so now you can put 8 pi over pi and then cancel out the pi's, or you can say right now the pi's cancel, and that's 8. All right, 2 more. Why don't you pause the video and try these yourself if you haven't done any yet. All right, let's see how you did. We have y equals 2 times the cosine of, I have a b value of 1/3, so I have to factor out a 1/3. That's x plus, factoring out is the same thing as dividing out. So I have to do 2 pi over 3 divided by 1/3. I don't divide by fractions, so instead I'm going to multiply by the reciprocal. The 3's cancel. That's 2 pi. All right, amplitude, this is cosine, so it has an amplitude of 2. Phase shift, this is left 2 pi. Vertical shift, there is none. Period, 2 pi divided by 1/3. I don't divide by fractions, so instead I'm going to multiply by the reciprocal, which is 3 over 1. So that's 6 pi. Last one, the b value is 6. So I have y equals -6 times the sine of. I'm going to factor out the 6. X minus, factoring out means dividing out. I can divide pi by 6 in my head. It's pi over 6. Amplitude, it is sine, so it does have an amplitude. The amplitude's 6. The phase shift is right, pi over 6. The vertical shift is left, left down 5. Period, 2 pi divided by b, which is 6. I can simplify this fraction. 2 goes in here once, 2 goes in here 3 times. So the period is pi over 3. Okay, that's it for today's notes.